Hello students, today we shall discuss about a special type of conjecture taken from number theory. You know what conjecture is? Conjecture is a very special type of statement where you can show that statement to be true for particular examples, but in general you cannot prove that to be true. But the interesting part is that on the other way around you cannot prove that to be false also. So this is a special type of statement which neither you can show to be true for general nor you can prove that to be wrong. Now this conjecture is based upon prime numbers. If I tell you to list down the prime numbers which you know, how will you list it down? The very first prime number that you can start is 2, then 3, then 5, 7, then 11, 13, 17, 19 and so on. You all know there are infinitely many primes, but if you look at these primes, there are some pairs of primes which are very special. For example, 3 and 5, 5 and 7, 11 and 13, 17 and 19. Why they are very special? If you look at these primes, you only have one non-prime in between them. For example, 3 and 5, 4 is between them, 5 and 7, 6 is between them, 11, 13, 12 is between them and so on. These type of primes, pair of primes where you have only one non-prime between them, these are called twin primes. For example, here 3, 5 is twin prime, 5, 7 is twin prime. But 3 and 7 are not twin primes because in between 3 and 7 there are more than one non-primes. So if you have only one non-prime between two primes, you call those two primes as twin primes. For example, 29 and 31, these are twin primes, but 17 and what is the next prime? 19, then 23. 17 and 23, those are not twin primes. 17, 19 is twin prime. 23, 29 are not twin primes, but 29, 31 is a twin prime because in between 29 and 31 you have only one non-prime 30. So these are called twin primes. Now our conjecture is basically based upon twin primes. What is the conjecture? Let us see. Let us list down all twin primes that we have less than 100. 3, 5, then 5, 7, then 11, 13, 17, 19, 29, 31, then we have 41, 43, then we have 59, 61 and 71, 73. You have much more twin primes beyond 100, but for this time being let us list down these primes which are less than 100. Now let us do one thing. Let us multiply these numbers and see what the result is. So these are the products that you will have. 3 into 5 you get 15, 5 into 7 35, 11 into 13 143, 17 into 19 323, 29 into 31 899, 41 into 43 1763, 59 into 61 3599 and 71 into 73 5183. Now let us perform an interesting operation upon it. What we will do? We will add up the digits of the product that you have got. For example, you will add 1 and 5. So if you add 1 and 5, you get 6. Here we have got the number 35. So you will add 3 and 5. You will get 8. Add 1 plus 4 plus 3. Answer is 8. 3 plus 2 plus 3. Answer is 8. 8 plus 9 plus 9. What is the answer? 9 plus 9, 18. 18 plus 8, 26. 1 plus 7 plus 6 plus 3. 1 plus 7, 8 plus 6, 14 plus 3, 17. 3 plus 5 plus 9 plus 9. 3 plus 5, 8 plus 9 plus 9. You have 26. At last you have 5 plus 1 plus 8 plus 3, that is again 17. Now, for the first four you got a single digit. We will not stop this until and unless you get a single digit. For example, here you have double digit, you will add up the digits once again. 2 plus 6, you get again 8. 1 plus 7, 8. 2 plus 6, 8. 1 plus 7, 8. Now look at the final number which you have got each time. 6, 8, 8, 8, 8, 8, 8, 8. If you omit the first case of twin primes, in all other cases you have reached the number 8 if you follow this sequence of operations. And I guarantee you, if you go beyond 100 and find more twin primes above 100, you will get the same result. Each time this sequence will end up to that number 8. Now if you think that, oh, let us try with non-twin primes, let us see if you get the number 8 or not. For example, 3 and 7, these are non-twin primes. 3 into 7, 21, 2 plus 1, 3. So you got the number 3. Let us try with another non-twin primes. Suppose 5 and 13. 5 and 13 is 13 into 5, 65. 65 means 6 plus 5, that is 11. Again 1 plus 1, 2. So each time you are not getting to a particular number. But in case of twin primes, each time leaving the first one, you will reach the number 8. That is the conjecture. I mean, you are seeing this, that it is holding true for all twin primes. You cannot find a single twin prime for which, apart from the first two, obviously apart from the first two, you cannot find any other twin primes for which these particular type of operation will not end to that number 8. But the interesting part is that you cannot prove in general this to be true also. If you can prove it, then let us know in the comment section. On the other hand, if you can find any other twin prime apart from 3 and 5, the first one, for which the number, this sequence will not end up to that number 8, then also let me know. Till then, goodbye. If you have liked this video, please share this video with your friends, subscribe to my channel and follow my page.